Hi everyone! We've been working on some long multiplication and I've had some questions about the ways that we're teaching long multiplication. So we start multiplication using manipulative, so making sure that the students understand that they're making these equal groups, they can skip count, things like that. But when we get to larger numbers, that's when we as adults really were taught that standard algorithm, so placing the bigger number and then the smaller number underneath it, multiplying, carrying, using placeholders, and then adding up all those numbers, those partial products underneath. We have found that students have a hard time remembering either to carry or they lose their place the larger the digits get, they forget those zero placeholders, and so we have moved into teaching the box method as kind of like an in-between. So the way that you do the box method is you look at your problem, 3 times 28, and then you basically decompose or break the numbers apart into expanded form. So 28 is 20 plus 8, and then each number that you have gets its own box. So the 20 from 28 goes above one box, and the 8 goes above another. For this example, we're only multiplying by one digit, so there's only one box down. And then you just look to see, well, the 3 and the 20 meet right here, and so you just multiply 3 times 20. This makes thinking about multiplication a little bit easier. We've talked about multiplying by powers of 10, so the students just multiply 3 times 2 and get 6, and then they know that they have that extra 0 and they bring it right down. Then they move over and they see that the 8 and the 3 meet in this box, so it's again just another basic math fact. 3 times 8 is 24. And then what they do is they add their partial products to get the total product. This same idea works for larger numbers as well. And so you can see in this problem, 45 times 35. The 45 is broken or decomposed into expanded form to make 40 plus 5. And in this example, the 40 and the 5 were put vertically. And then the 35 is broken into expanded form to make 30 plus 5, and those are placed along the top. Now, because we can multiply in any order, the 45 could have been put here and the 35 could have been put here, so it doesn't matter. But the idea again is to break these into basic math facts so that students have a little bit easier time manipulating their numbers as they're learning those math facts. So the 40 and the 30 meet together in this box, so we multiply 40 and 30. So 4 times 3 is 12, and then there were 2 zeros in the problem, so 2 zeros get added onto that 12 to make 1,200. The 40 and the 5 meet here, so in this case, the students need to remember that the 4 times 5 is 20, so there's a 0 just in that product, and then the 0 joins to make 200. 30 and 5 meet in this box for a partial product of 150, and then the 5 and the 5 meet in this box for a partial product of 25. The students would then add all the partial products. We typically just add straight this way, so we would, if you look at your students' work, you probably would see a 1400 here, and then a 175 here, so they just have the two numbers to add, and they get a total answer for their overall product. So that's the box method for multiplication that we've been practicing in a little bit in whole group, but mostly in small groups as students have been ready for it. So if you've seen things come home and are looking to practice with your child or just wondering what are they doing, this is an example for that. So just like we were using partial products to solve long multiplication problems, something that we do as an introduction to long division is partial quotients. The great thing about partial quotients is that it's very helpful for the students as they're learning their multiplication facts because they can use those and their knowledge of powers of 10 in order to do some long division without all of the work sometimes that goes into that traditional way that we as adults were taught in school. So partial division with division with partial products works like this. You have your dividend, 4,356 divided by 35. What it's asking the students to do is to just think of a number that they can multiply 35 by that they know. So I always have them start with 10. I know that I can multiply 35 by 10 and get 350. When I'm looking at such a large number, 350 isn't a big chunk that I can take out of that. So what if I tried sometimes just to double it to 35 times 20, because I can double my answer. Or in this case, since I have a number in the thousands, I could multiply by 100. So I still know that 35 times 1 is 35, and I can add 2 zeros to it. That gives me a really big chunk to take away from my dividend, 4,356. So I keep track of what I multiply by here on the outside. So I multiplied by 100 and I got 3,500. And then I subtract. Now I'm left with 856. So again, what chunk can I take away from 856? I can multiply 35 by 10 like I originally started and get 350. I can take that chunk away, end up with 506, take another group of 10 away, to subtract 350 again, end up with 156, and then the only really work here comes from a little bit of doubling work to see that I can take 4. Students probably would start with 1 or 2 at this point, and then you end up with either 0, which is what the problems that we've been doing have all divided evenly, or if you end up with a number when you subtract that's lower than your dividend, you know that you're done. So to get your final answer, you add up all of these numbers that you multiplied by. So if we add 100 plus 10 plus 10 plus 4, we get 124. So that's the quotient. And then if there's 0, then there's no remainder. If there is a remainder here that's less than your divisor, then that ends up being your remainder. So again, it's just more helpful for students to be able to use that multiplication because it's something they're just starting and getting familiar with than trying to remember all the steps for long division and work on guessing and checking some numbers to get all of your traditional quotient numbers up here that we would have used when we were being taught. Like for long multiplication using a box method, there is a box method for division, and this is the strategy that we will be working on in small groups this week. This is what I found is the most effective and most easy for our students at this age to understand when they are getting into those long division concepts. So you can see the problem is 316 divided by 4. So you put each digit in its own box. The 3 here, the 1 here, and the 6 here. You make kind of like longer columns for each, and then your divisor goes on the outside. So then you just go through and think, what or how many groups of 4 can I make with 3 things? Well, I can't here, so 0 goes on top of this column. And then you just multiply. 0 times 4 is 0. You subtract and get 3. Anything left over in this column comes up and joins, not adds to, just joins to make a new digit in the next column. So I already had the 1 here from 316, and the 3 that was my kind of remainder, or my difference here, joins to make 31. So then I think, how many groups of 4 can I make with 31 without going over? So that just goes back to those multiplication facts that the students are learning and is a little bit easier for them to work with. So I can make 7 groups of 4, so I put the 7 on top of that column and then multiply. 7 times 4 is 28. So then I'm subtracting, and I just have these smaller numbers that I'm working with and subtracting, and when I subtract correctly, I get 3. That digit comes over and joins the last digit here to make 36. How many groups of 4 can I get out of 36? And in this case, it's 9, so I multiply 4 times 9 to get 36 and end up with 0. And then you just look to see what number formed from the top from all that work, and that is your end answer, your quotient. So 316 divided by 4 is 79. If you get to the last column here, this last box, and you have a number that's not 0, then that just ends up being your remainder. This, again, is the method that I find clicks the most with the students and they understand the most at this age. So I'm really excited to get working with them this week on this. I hope this was a helpful video. I just wanted to give you some insight on the different strategies that we're using because it is definitely very different from when we were in school. So I hope this is helpful.